Imagine trying to teach 10 million people how to, like, operate radar systems or navigate
Or
warships.
fly long-range bombers, yeah.
Exactly. And do it all in a matter of months. And if you fail, you literally lose a world war. You can't just hand 10 million terrified recruits a dense textbook, wish them luck, and send them to the front lines.
No, definitely not. That would be a disaster.
Right. So how do you actually do it? How do you engineer human understanding on that scale? Well, whether you are prepping to design a training module for your team or catching up on learning trends for a big meeting, or you're just insanely curious about how humans are taught to do, well, anything, you are in the right place.
Welcome to this deep dive.
It is fantastic to be here. We are looking at a genuinely fascinating topic today. It's the hidden architecture of human learning.
Exactly. When you take a class or, click through a corporate training module, you usually just see the surface layer, like the video, the multiple choice quiz, the instructor talking at the front of the room.
Just the tip of the iceberg. Yeah, exactly. But beneath all of that is a massive, invisible infrastructure. And today, our mission is to explore that hidden architecture. We are tracking the history and the incredible evolution of instructional design, or IDDIE for short.
Right. And to do that, we're drawing on a really rich stack of sources. We have a deep systemic mapping analysis by Özgen and colleagues that looks at modern online ID models.
Which is super dense, but fascinating.
Oh, absolutely. And we're pairing that with some fantastic historical timelines from Instructional Design Central and ELB Learning.
Yeah, we're going to be geeking out hard on this. Just two passionate instructional design nerds keeping this history lesson fast, highly conversational, and getting it all done for you in under 20 minutes. Okay, let's unpack this. And we're starting with the guy you have definitely heard of, Thomas Edison.
Ah, yes. The light bulb guy. Though, in the early 1900s, he was equally obsessed with motion pictures.
Right. So in 1913, during what was known as the visual instruction movement, Thomas Edison makes this very bold, wildly inaccurate prediction.
Oh, it's so famously wrong.
It really is. He looks at his film reels and declares that books will soon be completely obsolete in schools. He genuinely thought you could teach every single branch of human knowledge just by, sitting kids in a dark room and projecting a film.
It's such a classic example of how society constantly get swept up in the hype of new media,
Yeah.
During that era, these school museums were popping up everywhere.
School museums.
Yeah, they were filled with stereographs, slides, and films. But teachers largely resisted it. And they weren't just being Luddites. The technology was clunky. It was dangerously flammable.
Oh, wow. Right. Early film was basically explosive.
Exactly. It was expensive, and frankly, the films just weren't that instructional. They were novelties. I mean, you can't just show a video of a chemical reaction and assume a student now understands chemistry.
Right. So the shiny new gadget didn't change the world of learning. It actually wasn't until a massive global crisis hit that instructional design became a formal, rigorous discipline. And the real catalyst was sheer panic. It was World War II.
Which brings us back to your opening scenario. The U.S. military suddenly faced an unprecedented logistical nightmare, training over 10 million personnel rapidly and, consistently across the globe.
Right, because before this, education was mostly the traditional apprenticeship model, or just sitting in a lecture hall taking notes.
Yeah, mostly theory-based.
But the military couldn't afford to have a pilot theorize about flying. They needed the pilot to pull the correct lever when the engine caught on fire.
Exactly. So they bring in psychologists and educational researchers, people like Robert Gagne. He steps in to create systematic training for the Army Air Force. And he didn't just throw information at them.
What did he do instead?
He used rigorous task analysis. He would look at a complex job, like operating a bomber, and break it down into the smallest possible sequence of steps. He realized that different types of learning required totally different conditions.
Wait, what do you mean by different conditions?
Well, you don't teach a physical motor skill the same way you teach a cognitive strategy.
Yeah.
Like if I'm teaching you to physically assemble a rifle, you need hands-on repetition.
Muscle memory, basically.
Right. But if I'm teaching you how to read an enemy radar signature, you need visual discrimination and immediate feedback. Gagne engineered the training based on the specific type of outcome required. And this wartime experiment yielded dramatic, measurable results.
Which perfectly explains why the 1950s and 60s became the behaviorist era. The military proved that if you manipulate the environment, you can control the behavioral output. This is where B.F. Skinner introduces programmed instruction.
Yes, the famous Skinner boxes, but for people.
Basically, it's the idea of breaking learning down into tiny sequential steps, asking frequent questions, and giving the learner immediate feedback.
It's also when Benjamin Bloom drops his famous taxonomy in 1956, breaking human learning down into cognitive, psychomotor, and affective domains.
Right, the domains of learning. And we cannot forget Robert Major in 1962. He creates a really rigid framework for writing behavioral objectives.
The holy grail for instructional designers.
Seriously. He said every learning goal must have three things: performance, conditions, and criteria.
Which is something we absolutely still use today, by the way.
Yes. If you are listening to this and you've ever had to sit through a corporate compliance training that started with a slide saying, by the end of this module, you will be able to identify a phishing email using your inbox with 100% accuracy.
Yep, you are directly experiencing the legacy of 1960s behaviorism.
It is everywhere.
That is Major's exact framework. Performance is identify the email. Condition is using your inbox. Criteria is 100% accuracy.
But I have to push back a little on this whole era. Looking at all these rigidly defined, measurable behaviors, it sounds like they were treating human beings like early computers.
What do you mean?
Like if I just input the right data, turn the crank, I can wait for the physical printout of a specific behavior. It feels incredibly mechanical and honestly a little soulless.
It was highly mechanical. Your analogy of treating humans like computers is actually spot on. But we have to understand the mechanism of why that mattered so much at the time. Okay, why was it so necessary? Because before behaviorism, education was incredibly abstract. A professor talked, you listened, and hopefully, learning occurred in the ether of your mind. What these pioneers were doing was grounding learning in observable reality. Have you ever seen Edgar Dale's Cone of Experience from 1946?
I have, yeah. It's like a pyramid, right?
Yes, exactly. Dale mapped out how learning deepens as you move away from the top of the pyramid, which is just abstract words, and text down toward the base, which involves concrete, direct, purposeful experiences.
So making it real.
Right. They wanted to guarantee that a mechanic could actually fix the tank, not just write a lovely essay about the theoretical properties of tank treads. Behaviorism was the tool to ensure absolute baseline competency.
Okay, that makes sense. I get that. But behaviorism has a massive flaw, doesn't it? It is great for teaching a soldier to assemble a rifle blindly, but what happens when the rifle jams in a completely novel way they've never seen before?
Right. The limits of conditioning.
Yeah, behaviorism doesn't teach you how to think, it teaches you how to react. They needed problem-solving skills, which meant they eventually had to look inside the brain.
Exactly. And that transition from behaviorism to cognitivism, from caring only about outward actions to caring about inward thought processes, that was massive. But before we get to the psychology of that, we have to talk about the institutional catalyst.
Another crisis.
Yes, because once again, a global event changed the trajectory of how we learn. In 1957, the Soviet Union launched Sputnik.
Wait, Sputnik. The satellite. How does a Soviet metal sphere in space change how an American HR department trains its employees?
Because it absolutely terrified the American establishment. The U.S. government thought, oh no, we are falling behind in the space race. Our science and math education is failing.
Panic funding.
Exactly. So they poured unprecedented federal funding into education and instructional technology. Suddenly, instructional design wasn't just a niche military experiment. It had massive institutional and academic support.
Got it. And out of that massive funding wave, specifically at Florida State University working with the military, we get the birth of ADDIE, which stands for Analysis, Design, Development, Implementation, and Evaluation. It becomes the absolute gold standard framework for building any kind of training.
Right. ADDIE gave the industry a universal project management structure. But while the structural process was getting formalized, the psychology, as you mentioned, was shifting toward cognitivism.
Yeah, the sources highlight Charles Regeluth's instructional design theory here. He really pushed this idea that we needed to stop treating the brain like an empty bucket we just dump facts into.
A very necessary shift.
Right. We needed to figure out how to actively facilitate the internal cognitive process.
Yes. Cognitivists ask things like, how does working memory function? How do we encode information into long-term storage? This is where concepts like cognitive load theory eventually come into play.
Okay, let's do a Quick explainer on that for the listener because it's so fundamental. Think of your brain's working memory like a very small whiteboard. If I am teaching you a complex medical procedure and I show you a diagram with 50 different arrows, tiny text, and flashing colors.
It's way too much at once.
Exactly. Your whiteboard instantly fills up. You literally have no space left to process what it means. Your cognitive load is maxed out and learning crashes.
Precisely. Cognitivism was all about designing instruction to optimize that whiteboard space.
Yeah.
And this focus on the brain's processing power happened to perfectly coincide with the arrival of actual computer processing power.
Oh, like the 1980s computer boom.
Yes, the Apple II, early IBM PCs, we start getting tools like HyperCard in 1987, which allowed non-programmers to link interactive content together. We get the Plato system, which remarkably had early versions of message boards, email, chat rooms, and remote screen sharing.
Which brings us to the most famous academic throwdown in instructional design history, the great media debate of the 1980s between Richard Clark and Robert Kozma.
Ah, yes. This raises an important question, one that still plagues the industry today, especially now with AI. Does the technology, the actual medium we use to deliver the instruction, change the learning outcome?
And Richard Clark argued absolutely not. He had this famous analogy. He said that instructional media is just the truck that delivers our groceries.
A very bold statement.
Right. He argued it doesn't matter if your groceries arrive in a shiny new delivery truck or a beat-up old sedan. The nutritional value of the food is exactly the same. The medium is just the vehicle. The instructional method is the food.
But Robert Kozma strongly disagreed. Kozma argued that you can't separate the medium from the method. The unique capabilities of the technology, like being able to branch scenarios based on a user's choice, click on interactive diagrams, get immediate digital feedback, those capabilities fundamentally change how the learner's brain interacts with the information.
I have to say, I am entirely Team Kozma on this. If Richard Clark says the truck doesn't change the nutrition, I don't buy that. What if the delivery truck has a built-in high-tech kitchen?
Oh, I like where this is going.
Right. What if, while it's driving to your house, it's chopping the vegetables, cooking the meal, and pre-digesting the complex information so your body absorbs it 10 times faster? A highly interactive digital simulation does exactly that for your brain's cognitive load. It does the heavy lifting so you can focus on the problem solving. It absolutely changes the nutrition.
That is an excellent way to reframe it.
Yeah.
The technology allows for methods that wouldn't be possible otherwise. And this debate was just a warm-up, really, because that delivery truck was about to turn into a global superhighway. In 1991, the World Wide Web goes public.
And geography is no longer a constraint. The browser becomes the training room. But early on, it was the Wild West. Everyone was building digital courses, but they were using different code, and they were constantly crashing the learning management systems, or LMS platforms, that companies use to track training.
Oh, it was total chaos. If you bought a course from vendor A, it wouldn't play on the LMS from vendor B. It was a nightmare. So in 1998 and 1999, the U.S. Department of Defense steps in again and drives the creation of SCORM.
The Shareable Content Object Reference Model?
Exactly. It was a technical standard. It ensured the digital learning modules could actually talk to the LMS reporting scores, tracking progress without crashing the system. It was universal packaging. And right around that same time in 1999, an expert named Elliot Mazie is at a conference and officially coins the term e-learning.
Wow, so the digital industry finally had a name.
Yes, it finally did.
But just putting old behaviorist click-through courses on the internet wasn't enough. With this digital scale came another massive pedagogical shift. We moved to constructivism.
Right. Constructivism is the idea that learning isn't just acquiring information from an authority figure. It is an active process of constructing your own meaning through authentic, real-world tasks.
And as Web 2.0 arrived with, social media, blogs, and wikis, that evolved into connectivism. This is the theory that learning happens through our network of connections.
To understand the mechanism of connectivism, think about how you solve a complex software or coding problem today at work. You don't read a linear training manual from start to finish.
No, definitely not.
You search a forum, you find a piece of code from someone in Germany, you read a comment from someone in Japan explaining why that code is broken, and you synthesize a new solution yourself. The network itself, i.e. the classroom.
Which perfectly explains why 2012 was hailed by the New York Times as the year of the MOOC. Massive open online courses, platforms like Coursera and ADDIE. It was this beautiful utopian vision.
The theory was so pure. Let's just take the world's best professors, record their lectures, put the content online for free, and give millions of people access to a Harvard or MIT education.
Except, it didn't work. The dropout rates were astronomical. We realized very quickly that access is not the same thing as learning.
Why do you think that was?
Because they ignored the human element. They just used the internet as a really big delivery truck for a traditional lecture. But learning requires friction. It requires accountability, social pressure, and tailored feedback. If you are sitting alone in your living room watching a video and nobody notices or cares if you pause it and walk away.
So just walk away.
Exactly, you walk away.
That is exactly where quality instructional design became the main differentiator. You couldn't just dump content online. As the systemic mapping analysis by Ezgen and colleagues shows, the old models had to adapt.
Right. The Ezgen study is fascinating because it maps out how specialized these models became. You couldn't use a slow, rigid process like ADDIE anymore. If you take 6 months to analyze and design a software training course using ADDIE, the software has already updated by the time you launch it.
So true. So we see the rise of agile models like SAM, the successive approximation model. SAM relies on rapid, constant prototyping. You build a quick, messy version of the course, test it with real users immediately, get feedback, and iterate.
The study also highlights incredibly specialized frameworks like eNeuroAnat-CF.
Which is quite the acronym.
It really is. But it's an incredibly specific framework designed exclusively for neuroanatomy e-learning. It heavily focuses on managing cognitive load. Tying back to our whiteboard analogy, if you overwhelm a medical student's brain with complex, interactive 3D brain diagrams without structuring it perfectly, learning stops.
It just crashes.
Exactly. They also highlighted the 6P4C model for nursing, which explicitly focuses on building civility, community, and safe spaces for intellectual play online.
Because nurses don't just need facts. They need to know how to communicate under pressure in a high-stakes team environment. You have to design the social space, not just the content.
Here's where it gets really interesting. With all these specialized models and digital tools, the role of the professional totally morphed. We went from being content factory workers, just stamping out score modules on an assembly line, to becoming learning experience designers, or LXDs. We started acting like architects, designing entire digital ecosystems for the learner to live in.
And that perfectly aligns with Regelu's paradigm shift, which the Ezgen study emphasizes. Instructional design had to abandon the rigid, content-centric approach. It became a fluid, learner-centered paradigm. You are not just organizing facts anymore. You are designing for motivation, for social interaction, for real-world application. You are building an environment.
Which brings us to Act 4, the Great Acceleration and the AI Architect. We spent 20 years slowly building this massive digital ecosystem, and then
a global pandemic forced the entire world to live in it permanently.
COVID-19. What would have normally taken a decade of gradual digital adoption happened in a matter of weeks. Instructional designers went from being a quiet support function in the HR basement to being mission-critical overnight. Every school, every corporation, every training facility had to go virtual instantly.
And right as the dust was settling from that pandemic shift, November 2022 happens. ChatGPT drops. Generative AI floods into the learning and development space.
It changed everything. Suddenly you have AI authoring tools, voice synthesis, instant translation, and personalized learning engines. You can ask an AI to write a storyboard, draft learning objectives, and code a branching interactive scenario in 30 seconds.
The efficiency is staggering.
Yeah, the job changed drastically. Designers are spending way less time writing out multiple choice questions and way more time curating, evaluating AI output for hallucinations, and acting as that high-level strategic architect we talked about.
If we connect this to the bigger picture, looking back across all our sources today, there is a powerful 80-year through line here. Whether you are Robert Gagne holding a film reel in a World War II hangar, or you are a modern learning experience designer prompting ChatGPT to build an adaptive simulation, the core discipline of instructional design hasn't actually changed.
Wait, really? With all this insane technology, you think the core is the same?
Absolutely.
Yeah.
Because we are still fundamentally asking the exact same three questions.
Right.
Number one, what do learners actually need to be able to do in the real world? Number two, what cognitive and environmental conditions best support that learning? And number three, how do we reliably evaluate if it worked?
That is so true.
The technology changes the speed and the scale, but the systematic, evidence-informed pursuit of human performance remains exactly the same.
That's an incredible way to look at it. And for you listening right now, think about how you are experiencing AI in your own learning. When an AI tool summarizes an article for you or generates practice interview questions based on your resume, you are living through the next major era of instructional design history. You are part of the experiment.
We're rapidly moving toward a future of genuinely personalized adaptive learning at scale, where the system adjusts the pacing, the difficulty, and the content in real time based on your specific cognitive performance.
Which is mind-blowing. But before we get completely lost in the future, it is time for our outro. We promised you 5 facts you probably didn't know about the history of instructional design, drawn straight from our sources. Let's rapid-fire these. You ready?
Let's do it. Fact number 1. Thomas Edison genuinely believed that motion pictures would make textbooks completely obsolete in schools. He made that very confident prediction way back in 1913.
Fact 2. The word e-learning isn't nearly as old as you might think. It didn't exist until Elliot Mazie officially coined it at a CBT Systems conference in 1999.
Fact 3. The foundational ADDIE model analysis, design, development, implementation, evaluation, which is used in almost every corporate training department today, was originally developed at Florida State University to train the U.S. military.
Fact 4. You can thank the Cold War for modern instructional design. The Soviet Union's launch of the Sputnik satellite in 1957 directly triggered the panicked federal funding that shaped American instructional technology.
And fact 5. A famous 1980s academic feud between Richard Clark and Robert Cosma literally centered around whether teaching technology is just a grocery delivery truck that doesn't change the nutritional value of a learning experience.
I'm still Team Cosma on that one, by the way. If the truck has a kitchen that pre-digests the meal, the nutrition changes. But this brings us to a final provocative thought for you to mull over as you go about your day. We've talked a lot about systems, cognitive load, and technology. But if AI eventually gets so good that it can instantly generate perfectly personalized, highly interactive, adaptive learning for every individual in real time, what happens to the human element of teaching? Are we, as instructors and designers, destined to just become the emotional support for the algorithm?
That is the existential question of our era. If the machine can flawlessly manage the cognitive load and deliver the information, what is the human's role? Is it just empathy, motivation, social friction, and it challenges the very definition of what it means to be a teacher?
It really does. It leaves a lot to think about. If you enjoyed this deep dive, be sure to subscribe so you don't miss our next one. We love taking these complex topics and breaking them down for you.
Thank you for joining us on this journey through the hidden architecture of learning.
So what does this all mean? It means learning never stops. Whether it's a jerky black and white film reel, a rigid behavioral objective, a delivery truck full of groceries, or a generative AI algorithm, the drive to figure out how we understand the world is beautifully, stubbornly human. Keep learning, and we'll catch you next time.